All right, kiddos, here we are today. As you know, yesterday I walked you through a lot of this. So you're going to be doing the Cavendish lab again. I walked you through a lot of it. We already answered this pre-lab question, and we've moved on. I have placed this link on my teacher page, which you're already on because I told you to go there when we walked in. So that's there. You should be all right to go up here and start. Now, yesterday, if you go and repeat this lab, the numbers here are going to change slightly because the distance between the objects is different than what I used yesterday. It really doesn't matter which one you chose. So what we're going to do is just continue here. If you didn't finish these, go and finish these. Remember, these need to be in scientific notation. So the number should be times 10 to the minus 10 or minus 9. So they're very, very small numbers. All right, we did answer this yesterday in class also. If not, make sure you fill that in before you move on. So I'll walk you through this section here because I didn't get this through everybody yet. So we're going to set each mass to 10 grams. So when we start our activity, we'll set each mass to 10 grams. All right. Move the ruler so 0 is in the center of the blue mass. What I did yesterday was I moved the person. Well, you can actually move the ruler. So set it up so that it's more or less 0's there. And so that the red mass drag the center to be 3 meters. So I'm going to drag this guy over to be at 3 meters. Now you can see here I'm slightly off, and that'll be fine. I can try moving it just a little bit, but get as close as you can. That means your numbers and your neighbor's numbers might be off slightly. So you might have 753 like I do. Somebody else might have, 824 because they're a little bit closer, or 648 because they're a little further away. But it's fine as long as we keep this consistent at 3 meters. So I'll move the ruler out of the way. And now I've got this number, 753. So I'm going to move the decimal place over 3, 6, 9, 10. So when I get to here, I should have 7.53 times 10 to the minus 10. So record that, or whatever yours is saying. The next thing you're going to do now is you're going to make predictions, record the value, and then see what the result is. Okay? So I'm going to open up a account here, a Drive account, or a Google Doc here, just so that I have a way to type and show you the actual answers that I'm looking for. Okay? So here we go. And I just lost the box. All right. Just like I did yesterday, I'm going to show you what the values should be here. So I'll make them nice and big so everybody can see them. And then we'll go back to where I was. Sorry. If you're still paying attention, bravo, you've made it this far. All right, so we're at part 2 again. So let's see if I can copy and paste this. You don't have to do this. I'm just doing this so that it doesn't translate at all, so that's awful. So I'm just going to write it in here. I'll insert a table and make it go just 4 across so that it will mimic these columns. I'll do C, D, and E. So C, D, E. And this will be A and B, just so that we're all on the same page. Okay, so first one was 10 and 10. This thing was blacked out. This thing was blacked out. So this one should have, according to our lab, 7. Mine, yours will be a little bit different, and that's okay. 7.53 3 times 10. And then you need to go here, format, superscript, the minus 10. Okay? So there we go. And we'll just send it so there. Now that should kind of look like yours. Okay? So now what we're going to do is it's asking you to make a prediction. The whole goal here is to figure out what happens when we change the masses. We're going to predict what happens to the force. Is it going to be more or less or the same as the initial amount? Then we'll actually do it and record the amount, and then we'll figure out if it's doubled, halved, or tripled, or quadrupled, whatever it might be. There's a little trick to that, and I'll show you that in a second. So here we go, 10 and 20. So change this one up to 20. Well, first, make our prediction. If I increase the mass, is this number going to get bigger, smaller, or remain the same? So this one is 10 and 20 predicted here. So I want increase or decrease or same. Your choice. Make a guess. There's no right or wrong answer there. All right? So now that you got that done, now let's go and see what actually happens. So move this up to 20, and the force becomes 1.505. Or when we convert it to scientific notation, we would have 1.505 times 10 to the negative, and then let's go back and look at that. We moved over 3, 6, 7, 8, 9 spots. So to the minus 9. Now here's the problem. To really compare this one and this one, it might look to you that this number is smaller because 1.5 is smaller than 7.53, but that's not actually correct because we have to keep the exponents the same. So to do that, we need to either move this one over to the right again to make it to the minus 10 or move this one over to the left to make it to the minus 9. What it does is it doesn't give us the correct format of scientific notation, but does allow us to compare actual apples to apples, the same number. So I'm going to move this value over and make it 1.5, okay, from 1.5 to 15.5, so that makes this to the minus 10. Now that isn't correct, is not correct scientific notation, but it makes it much easier to see now the effect. What happened to this number compared to this one? Well, you can see 7 times 2 is roughly 14, and a half is another 1. So you can see here that this doubled. And that's the answer we'd be looking for. All right? So we're going to have to do this odd type of conversion here every time just to make your answers correct. So the next prediction is 30 and 10. So if I go to, sorry, I had that backwards, not that it mattered. So 30 and 10. So what do I have to do now? Make a prediction. Comparing this value to what this will be. Is it going to increase, decrease, or be the same? I only want one answer. I'm not going to give it to you. So choose. All right, now let's go and do that. So back over to the lab and go up to 30. And we can see here the value is 2258. So this would be 2.258. So 2.258 times 10 to the negative, let's go back and see what that was, 369. Okay. So again, let's move this over now. So we'll change this again. So we'll make this 22.58 times 7 minus 10. What is that?